Good morning, students. Jai Swaminarayan. Today we are going to start chapter 8, binomial theorem. This is a very hot favorite topic for JEE mains as well as advanced. Students, no examiner can bypass binomial theorem in any of the competitive examinations. Students, nobody can bypass this particular chapter. Now students, if I take a plus b to the power 1, the expansion is a plus b. If I take a plus b the whole square, it is a square plus twice ab plus b square, coefficients being 1 to 1. If I take a plus b the whole cube, it is a cube plus 3 a square b plus 3 ab square plus b. This is what all of you have studied in your lower standards up to say standard 10th. If I ask you, tell me the expansion of a plus b the whole cube, students, you will immediately tell me this formula. But what if your power or index is more than 3, suppose 6, 8, 10, 9, 7, like that index, a plus b to the power 7. So if I ask you to tell me the expansion of a plus b to the power 7, students, then definitely you don't know till date. But after this lecture, I assure you, you will tell sir, this is going to be done by using binomial theorem. So students, what is the theorem in the formula? Given by our most respected Sir Isaac Newton, and this was invented by Sir Isaac Newton, students, in order to apply this in physics. This wasn't an individual mathematical topic. This was invented to apply in physics, and the formula goes this way. I am writing here a plus b to the power n. Students, proof of the formula is using the principle of mathematical induction, the theorem. The formula, students, is proved using mathematical induction. Let me write little below, students, so that you can understand. Now, pay attention, students. The formula of binomial theorem goes like this: a plus b to the power n. A and b are real values, and the index or power, students, is a natural number. Students, I say natural number. We have to focus on only the first term in the expansion, and it goes like this: n c0 a to the power n b raised to 0. I box it for our convenience. It goes in this way: n c0 a to the power n, students, b raised to 0. Now, in the subsequent terms, now students, in the subsequent terms, 3 changes we have to remember. This is the first change. This is R. It increases by 1. Power of A decreases by 1 and power of B increases by 1. So 2 increment and 1 decrement. R increases by 1, power of A decreases by 1, power of B increases by 1. So the next term will be NC1, A raised to N minus 1, B raised to 1. Check. R increases by 1, power of A decreases by 1 and power of B increases by 1. So 3 changes in subsequent term. Okay, next. R increases by 1, power of A decreases by 1, power of B increases by 1. So the third term is NC2, A raised to N minus 2, B raised to 2. Up to the last term will be NCN, A raised to 0, B raised to N. Again, I am boxing this for our convenience. If you observe, students, the 2 boxes very perfectly, then you will understand in the first term we have maximum power of A, which is N, and minimum power of B, which is 0, which flip-flops in the last term. Check. Here the power of A becomes 0 and power of B becomes N. Here the power of A was N and the power of B was 0. So in the last term, students, the power of A and B are flip-flopped. We start with minimum power of B and end with maximum power of B. Or we start with maximum power of A and end with minimum power of A, which is, students, 0. This we have to perfectly understand and memorize. So only memorize the first term, which is NC0, A raised to N, B raised to 0. In the next term and succeeding terms, 3 changes. In NC are basic content. This R increases by 1, power of A decreases by 1, and power of B increases by 1. So R and B increases by 1 and power of A, students, decreases by 1. This is the binomial theorem formula, or this is, students, the expansion of A plus B to the power N, where A and B can be any real values and index of power is a natural number. So students, if you remember the first box, if you remember and memorize the first term, I am very sure that this cannot be a problem at all and the concept is done. Now students, in this formula, NC0, NC1, NC0, NC1, NC2, NC3 up to NCN are called binomial coefficients. This simplification then for a given n will be a number. So students, in this expansion, NC0, NC1, NC2, NC3, etc. are called binomial, students, coefficients. Now, students, all of you are aware of this. A plus B to the power 1. It is A plus B. By logic logic of writing was to be justified, which I am justifying. A plus B, the whole cube will be this. Now, a famous personality, Blaise Pascal. He was all in one, a mathematician, a physician, a statistician, as well as a logician. Mathematician, physician, logic is a subject which is taught in arts. So he was a mathematician, physician, and you can say a logician. Now, he has given a shortcut table to realize this binomial coefficients, and that I am preparing now. So the next aspect is to go to prepare Pascal triangle. Pascal triangle. So the first column is index and the second column is binomial coefficients, and the first column is index or power. Students, this Blaise Pascal has given a fantastic approach to orally write binomial coefficients, so that I am highlighting it present. I am preparing till 6, you have to prepare till 8. My space is less, so I will be restricted to prepare up to 6. Now when power is 1, coefficients of A and B are 1, that we have written 1 and 1. So, in the expansion of A plus B to the power n, when index or power is 1, students, coefficients of A and B are 1. When index or power is 2, the first and the last coefficients are always 1. The middle one is the addition of, about to check, 1, 2, 1, and here 1 and 1. Here 1, 3, 1. So when index is 3, the first and the last coefficients are 1. Middle ones are addition of the above 2. Check 1, 3, 3, 1. Like that it is. First and last coefficients are always 1. When index is 4, first and last coefficients are 1. Middle ones 4, 6, 4. When index is 5, first and last are 1. Then 5, then 10, then 10, and then 5. When index is 6, first and last are 1, then 6, 50, 50, and 6. You can go on. I have less space to write. That is why I restricted myself up to 6. You have to prepare to 8. And whenever you sit to practice binomial theorem, 2 things always, students, you keep in mind. First of all, you should write the binomial expansion formula, and second thing, students, you should prepare Pascal triangle up to 8. So Pascal triangle is to realize, is to obtain binomial coefficients, students, orally. That is why this Pascal triangle, students, is very, very important. Now, students, so again I am revising the formula. Remember, in the formula formula, we have to only memorize the first term, which is NC0 a to the power n b to the power 0. In the succeeding terms, three changes: increase r by 1, decrease power of a by 1, increase power of b by 1. So second term will be NC1 a to the power n minus 1 b is to 1. Third term will be NC2 a to the power n minus 2 b is to 2. Fourth term NC3 a to the power n minus 3 b is to 3 up to the last term is NCn a to the power 0 and b to the power n. So in the first and last terms, the powers of A and B students are flip-flopped. In the first and the last terms, the power of A and B are flip-flopped. And we have already studied this in combination. NC0 is also 1 and NCn is also 1. Therefore, the first and the last coefficients are always 1. In the expansion, in the formula, NC0, NC1, NC2, NC3 up to NCn are called binomial coefficients. And these coefficients, without simplifying the formula of MCR, can be obtained from Pascal triangle, which was given by Blaise Pascal. That students we have to perfectly understand. Now, let us use this theorem. Let us use this triangle. Then only students you will be happy how this is applied. So we start with one or two sums of exercise 8.1. Now students, pay attention. In today's lecture we will exclusively apply the binomial theorem, which is the plus sign, which will be. So exercise 8.1 we will be doing sum number 4 and 5. Fourth sum we are starting with x by 3 plus 1 by x is to 5. Exercise 8.1 fourth sum, x by 3 plus 1 by x to the power 5. Here students, have patience and have, you can say, concentration. Have patience, go at ease. Only first term I have to memorize in the formula, NC0. Indirectly this is A, this is B, and this value is N. So first step, you compare x by 3 plus 1 by x to the power 5 with A plus B to the power N. Then 8 comes out to be x by 3, b is 1 by x, and n is 5. So the first term will be NC0, so 5C0, a raised to n, so x by 3 raised to 5, b raised to 0, so 1 by x raised to 0. This is how, students, we have to write the first term. N C0, so n is 5, so 5C0, a raised to n, a is x by 3, n is 5, b raised to 0, b is 1 by x. Now three changes: increase r by 1, decrease power of a by 1, increase the power of b by 1. So 5C1, x by 3 power of a is decreased by 1, power of b is increased by 1, plus 5C2, x by 3 the whole cube, 1 by x the whole square. So three changes if you adopt in the succeeding terms, you will never make any mistake. Then plus 5c 3x by 3 raised to 2 1 by x cube. Then 5c 4, decrease the power of a by 1, increase the power of b by 1. Last one will be ncn. A raised to 0, b raised to n. Here we stop. So this is, students, the basic application of binomial theorem formula. You never have to remember the entire theorem. Now, these are called Pascal, means binomial coefficients, which we will apply or which we will obtain from Pascal triangle. So I circle. And this you concentrate on. How to read this? Students, this first value is 5c0, 5c1, 5c2, 5c3, 5c4 and 5c5. You know the combination formula. NCR is equal to n factorial upon r factorial into n minus r factorial. But if I am using combination formula, this becomes very healthy. So if it is 6, then this will be 60, 61, 62, 63, 64, 65 and 66. So it starts with C0. So this is amazing, which was suggested by Blaise Pascal. So now I am only able to do 5c0 from Pascal triangle, and which is 1 x to the power 5, 3 raised to 5 is 243, anything raised to 0 is 1. 5c1, my second number is 5, x to the power 4, 3 to the power 4 is 81 into 1 by x. 5c2 is 10, my third number, this is x cube upon 27 into 1 by x squared, plus 5c3 is again 10, this is x squared by 9 into 1 by x cubed, plus 5c4 is 5x by 3, this is 1 by x raised to 4, plus 5c5 last number is 1, anything raised to 0 is 1, this is 1 upon x raised to 5. Patience and proper understanding are the only key to do the sums of binomial theorem, students. Final touch-up. This is equal to x raised to 5 upon 243. 1x and x gets cancelled, so this will be 5x cubed by 81. X squared and x squared gets cancelled, only x remains, so this is 10x by 27 plus x squared and x squared gets cancelled, 10 upon 9x plus 5 upon 3x cubed plus 1 upon x raised to 5, which is our answer. So after simplifying the terms, we do not go further. This is, students, our final answer. We do not simplify further. Students, this is our final answer. Observe, how many terms are there in the answer? If my power is 5, 1, 2, 3, 4, 5, 6, I have 6 terms in the expansion. So if power was 7, I would have got 8 terms. If power was 100, I would have got 101 terms. So in general, if your index is n, number of terms students in the expansion would be n plus 1. I repeat, if your index is 5, number of terms in the expansion are 6. If your index is 8, number of terms will be 9. In general, if your index is n, number of terms in the expansion will be n plus 1. Now students will do the first step, x plus 1 by x raised to 6. And thus Pascal triangle has facilitated us to simplify binomial coefficients without originally using students the formula of NCR. So students, this is simply superb, fascinating, interesting. Sixth sum, exercise 8.1. X plus 1 by x raised to 6. So this is A, this is B, and this is N. So first step, you compare x plus 1 by x to the power 6 with A plus B raised to n. So A is x, B is 1 by x, and n is 6. Only first term, x is 0, so 6 is 0. A is x raised to n is 6, b raised to 0, b is 1 by x raised to 0. That's all. Only first term. Now implement 3 changes. Increase r by 1, power of a by 1 you decrease, and increase power of b by 1. Increase r by 1, so 6c1, power of a you decrease by 1, power of b you increase by 1, plus 6c2, x raised to 4, 1 by x raised to 2, plus 6c3, x raised to 3, 1 by x cubed, plus 6c4, 1 decreasing the power of a by 1 and increasing the power of b by 1, plus 6c5x raised to 1, 1 by x raised to 5, last one, 6c6x raised to 0, 1 by x raised to 6. So within a minute you can write, students, all the terms in the expansion. Now, how to read Pascal triangle for index 6? The first term, the first number. This I have to focus on. The first number is 60, 61, 62, 63, 64, 65, and 66. So 60 is 1, x raised to 6, anything raised to 0 is 1. 61, second number is 6, x to the power 5 into 1 by x. 62 is 15, x raised to 4 into 1 by x square, plus 63 is 20 into x cube into 1 by x cube, plus 64 is 15 into x square into 1 by x raised to 4, plus 65 is 6, that we know, we have done this in chapter 7, and last is 1 into 1 by x raised to 6. So not at all difficult, but students, again and again and repeating, you have to be attentive and concentrating only on the powers of A and B. That is the main part of the sum. Simplifying, final answer, final touch. This is x raised to 6, 1x and x gets cancelled, 6x raised to 4, x square and x square gets cancelled, so 15x square, x cube and x cube gets cancelled, so 20. X square and x square gets cancelled, so 15 by x square. X and x gets cancelled, so x raised to 4. 1 on x raised to 6. Check number of terms are 7. The term without x is called constant term. Students, the term without x is called constant term in the binomial expansion. So something very interesting, something very fascinating. If index is 6, number of terms are 7. One more interesting observation, properties. In any term, the powers of a and b will add to n. Check 6 plus 0, 6, 5 plus 1, 6, 4 plus 2, 6, 3 plus 3, 6, 2 plus 4, 6, 1 plus 5, 6, and 6 plus 0, 6. So even you can cross check. In any term, in the expansion, powers of a and b always adds to n. Check here also. N plus 0 is n, n minus 1 plus 1 is n, n minus 2 plus 2 is n, 0 plus n is n. So in the expansion, the powers of a and b always adds to n. So this is, you can say, very interesting, very fascinating. And students, trust me, this is very, very important concept for JEE mains and advanced. And binomial coefficient is a shortcut. Binomial means Pascal triangle. Sorry. Pascal triangle is a shortcut to find binomial coefficients, which was given by Blaise Pascal. So instead of using the combination formula NCR is equal to n factorial upon r factorial into n minus r factorial, this triangle given by famous Blaise Pascal helps us to obtain only the binomial coefficients. This is also interesting. If index is 7, index is 5, check coefficients are 6. If index is 4, coefficients are 5, because number of terms is always one more than the index. So naturally coefficients will be also one more than the index. Okay students, we conclude the lecture. Write this formula 3 times and prepare Pascal triangle up to 8 3 times. Remaining students we will do in the next lecture. Formula 3 times and Pascal triangle 3 times up to 8. Thank you students.